Good morning, SE student. This is your math teacher. Miss you all. Hope you are all safe. Our lesson today is also about exponential function, the second part of it. Now, equalities and inequalities. How I can solve equalities or equations with exponential, e as ex equal a, and also inequalities with the exponential. Here are the rules. If ex equal a, it's admitted that x equal ln a, but that definitely a must be greater than 0. As an example, if we have e exponent x equal 2, what can I deduce in this case? Then x equal ln of 2. That's it, simply. But if ex equal ea, here I have the base is e and here the base is also e, so directly I can deduce that x equal a without any condition. Now if ex strictly greater than a, so I can deduce that x greater than ln a, similarly as for the equations, and also a here must be what? Greater than 0. Now if ex is strictly greater than a and a is less than 0, then x must, in this case, is any number. Why is that? Ex is positive for every value of x, since e is a positive number, which is equal to 2.7 approximately. Then I can deduce that x is any number. Why? Because this is positive number greater than negative. Now, if ex greater than ea, so directly they have the same base, directly I can deduce that x greater than a. Examples. Solve the following equations. Now, I have 2ex plus 5 equals 7. What I'm going to do, first of all, we take 5 to the second part. We obtain 2ex equal 2. Then I can deduce that ex equal 1. This is not enough. I need to determine the value of x. Then x equal, in this case, x equal ln of 1, which is 0. We remember that ln of 1 equals 0, or in fact I can replace x by 1 by e exponent 0, and here I have ex equal 1, so I can write it e exponent 0, and I can deduce that x equal 0 since they have the same base. Now, if 3ex plus 8 equal 5, I can deduce that ex equal negative 1, which is impossible since ex is a positive quantity, so no solution here. What about 3ex plus 5 equal 5? Here I can deduce that 3ex equals 0. Also, this is impossible. Why is that? Because ex is strictly greater than 0, cannot be equal to 0. Okay? Now, the fourth example, 2ex minus 1 equal 3ex plus 6. This is a null product. So if we have a times b equals 0, I can deduce a equals 0 or b equal 0 definitely. Now, but here I noticed something which is very important. First of all, I'm going to start by the same fact, by the first factor. 2ex minus 1 equals 0, then ex equal half. So I can deduce x equal ln half. Okay, this is not, or in fact it is enough to write here, but I prefer to simplify it, so I can write 1 over 2 as 2 exponent minus 1, which is equal minus ln 2. I prefer to reach this step. The second factor, 3ex plus 6 cannot be equal to 0. Why is that? Because this gives us ex equal negative 2, which is impossible because ex must be positive. Then the only solution for this equation is ex equal minus ln of 2. Now, here I have also an equation, ex minus 3 over 2 ex plus 5 equal to 1. Since here I have equal, yes, I can do the cross product. So we obtain minus ex equal minus 2, then ex equal 2. So directly I can deduce that x equal ln 2. What about this part? In fact, here I have e exponent 3x minus 1 equal 2. I can apply directly that if ex equal a, then x equal ln of a. So here I can write that I replaced x here by 3x minus 1. Then 3x minus 1 equal ln lat 2, so I can deduce that x equal, we take 1 to the second side of the equation, and then we divide by 3, we obtain x equal 1 plus ln lat 2 over 3. Now what about this example also? Minus 2e minus x minus 6 equal 2. I can write it minus 2ex equal 8, then e minus exponent minus x equal minus 4. Also this is impossible. Why is that? E exponent a must be greater than 0, whatever the value of a, and a x or a minus x, a2 or a minus 5, it doesn't matter. This quantity is positive. Then ex minus 4, e minus x equal minus 4, impossible, has no solution. If you want, you can write it like this, minus x equal ln of minus 4, and you know that this writing does not exist. So also this is impossible. Here I have ex square minus 1 equal e exponent 3. Since they have the same base, which is e, so I can deduce that the exponents are equal. X square minus 1 equal 3, so I can deduce x1 equal 1 and x2 equal, minus 2 and x2 equal 2. I have here another form or another type of equations. I notice here that I have 2e exponent 2x minus 3ex plus 1 equals 0. In fact, I can write it as e2 into ex exponent 2 minus 3ex plus 1 equal to 0. I notice that this is an equation leading to a second degree equation, so I can replace ex by t. The expression becomes 2, or the equation in fact becomes 2t squared minus 3t plus 1 equal to 0. I have here two solutions. The first solution, t1 equal 1, then ex equal 1, so I can deduce that x equals 0, because if ex equal 1, then x equal ln of 1, which is 0. Or ex equal, I think here this is this is 2. Okay, I'm going to correct it. Now I have t2 equal 1 over 2, so ex equal 1 over 2. Also here I'm going to correct it. So this is 2 and this is minus ln of 2. e2x minus, now another equation of the same type, e2x minus 3x minus 4 equal to 0. Then I can deduce that ex all of its square minus 3x minus 4 equal to 0. I can transform it into a second degree equation. So te equal ex. This becomes t squared minus 3t minus 4. Now the first one, I have t1 becomes minus 1. So ex equal minus 1, which is impossible. Then in this case, the second root is t2 equal 4, so ex equal 4, then x equal ln lat 4. Also I can write it as 2 ln lat 2. By the way, if they ask us to factorize this expression becomes 2t plus 1 into t minus 4 equal to 0. Then I can write it ex plus 1 into ex minus 4. Now, what about this equation? I have ex minus e minus x equals 0. I can't write it ex equal e minus x. Then I can deduce that x equal minus x. So I take minus x to the second side. This becomes 2x equals 0, then x equal 0. Now here I have something which is very important. In fact, I have e2x plus e minus 2x. This quantity is positive. And also this quantity is also positive. And I have positive plus positive gives us a positive quantity. And here we obtain minus 1, which is impossible, since positive plus positive gives us a positive quantity. Even I can write it like this. I can write e exponent 2x plus e exponent minus 2x, and I transform 1 to the second side equal to 0. Positive plus positive plus strictly positive. All of them are strictly positive, and the answer is 0, which is impossible. Now, here I'm going to give you some examples, but here with inequalities. Now, Ex greater than 0, this is true for every value of x. Why? Because Ex itself is positive. Ex less than or equal to 0, of course this is impossible. This is the converse of the first one. Now, Ex is strictly less than 1, then I can deduce that x less than len lal 1, and len lal 1 equal what? Equal 0. Then in this case, x is less than 0. Ex minus 2 greater than 0, then Ex greater than 2, so x is greater than len lal 2. Now, Ex plus 6 is strictly greater than 0. This is true for every value of x belongs to R. Why? Because this is a positive quantity, and this is a positive quantity. Positive plus positive is positive. Or I can even write it like this. Ex becomes greater than minus 6. Then this is a positive quantity, which is, of course, greater than a negative quantity for every value of x. What about this inequality? I have Ex minus 2 into 2Ex plus 3 less than 0. Since 2Ex positive and 3 positive, then this quantity is positive. Why? Positive plus positive is positive. So I can ignore it. And I'm working only with this factor. Ex in this case becomes minus 2 less than 0. So Ex less than 2, then x less than len lal 2. Here I have Ex minus 1 into Ex minus 3 greater than 0. First of all, I determine the root of this factor and the root of the second factor. I obtain the first factor gives us that x equal 0. The root of the second factor, x equal len lal 3. Then by using the table, the root of the first factor is 0. We applied same opposite. The coefficient of Ex is positive, plus, plus, minus. Here the coefficient of Ex also positive, and its root len lal 3, so I write plus, minus, minus. Directly then I can minus times minus plus, plus times minus minus, and plus. So the solution is the positive part, which is here. This is the positive part, and here the positive part. So x is between negative infinity and 0, and between len lal 3 plus infinity. Can I write it like this directly? In fact, yes, I can write x, and I write the product of the two factors. I have here minus infinity and plus infinity. I have here 0, len lal 3, and as we do in the second degree equation, I can directly write here same, opposite, and same, since the exponent of E is x only. Now, Ex minus 6, of course, this is another type of inequalities, over Ex minus 1 less than or equal to 1. Here we cannot do the cross product because we have here an inequality. And the equalities, yes, you can do it. 2Ex minus 6 over Ex minus 1, I can transform 1 to the second part. Minus 1 less than or equal to 0. Using common denominator, we obtain Ex minus 5 over Ex minus 1, which is less than or equal to 0. Here the root of the first one is x equal len lal 5, and here x equal 0. Also, we can use or two rows, or as I did in the previous preceding example. So I have here 0 len lal 5. The root of the first one is 0 here, but here we have restriction. So I can same opposite. Ex minus 5, this is the root, plus minus plus. And in fact, I obtain, here I have the negative, because I have here less than or equal to 0. So we can obtain the solution as from 0 till len lal 5. The last one, I have here e exponent 3x minus 1 greater than 1. So I can directly write it 3x minus 1 greater than 0, then x greater than 1 over 3. Also, why is that? Because 1 is